Then the next talk will be titled Bundle MCR Towards Conversational Bundle Recommendation, presented by, I hope I pronounce it right, Zhankui. The floor is yours.
Hello, everyone. I'm Zhankui from UC San Diego. Today, I'm glad to present our work, Bundle MCR Towards Conversational Bundle Recommendation. So first, let me introduce what is the bundle recommendation and what is the conversational recommendation. For bundle recommendation, it's defined as we have a recommender try to recommend multiple items as a set to the user so they can be consumed by the user at the same time. For example, an outfit. This is an example. Like the model can generate multiple items and recommend it to the user. But the traditional bundle recommendation has some challenges, such as the interaction sparsity or the output space complexity. It's like we don't know what is the bundle size of the correct number of the correct bundle. So it's really hard to define what is the size we should have for the target bundle. Also, when we consider the possibilities of all the combinations of different items in the bundle, the problem is really challenging to predict correctly in one shoot. So for this problem, what we want to do is to introduce an additional mechanism we call conversational mechanism into this problem. The conversational RecSys is defined as we try to recommend something to the user through a conversation. And the key of the conversation is to allow the system to ask some questions and collect the user answers. So the question and the answers can be based on some predefined attributes or categories from the item metadata, or they can be free text. For example, the question like, would you like the blue one? It can be generated by a natural language model, or it can be generated by a selected tag with the template. Whatever, the benefits of the conversational recommendation is, first, we are allowed to acquire the user feedback actively, and we can complete a recommendation progressively instead of in one shoot. So that can be pretty helpful for the traditional bundle recommendation. Okay, so that's what we want to do in this work. Compare with the traditional bundle recommendation that try to recommend the correct bundle in one shoot, or compare with the existing conversational recommendation that try to recommend single item to the user. What we want to do in this work is to build a model that can recommend a bundle of items through the conversation to the user. So now let's look at the formulation of this problem. We consider a scenario that's called MCR. MCR is multiple round conversational recommendation scenario. It's commonly used by some existing papers. And our task is to extend it from the individual item recommendation to the bundle-aware recommendation. And similar to the previous work, ours is also based on the tags from the item metadata. This is an illustration. There's a pipeline, and I will show an example about how to use it. For example, we start a conversation with the initial state, and later, the system can decide whether to ask some questions or recommend something to the user. So in the current conversation round, maybe system decide to ask something. So a model will call to select the correct tags, for example, the categories or the attributes to pose a question like, would you like the sports style pants with the white shoes? And then the user is allowed to provide some feedbacks to the user. So with the feedbacks, the system can update the states of the conversation. So in the next round, maybe the system decide to recommend something to the user because they have more information. Another model is called, because we decide to recommend something, this model generates a bundle or partial bundle to the user with multiple items. And user can also provide some feedback like, I like this, I don't like that, or I just ignore the proposal. And based on this feedback, okay, our model, the system can update the state again. So after multiple rounds, we can collect more and more information about user preference. So this conversation will end if we reach the maximum round of the conversation, or the user is satisfied with the current bundle we proposed. Okay, that's MCR for bundle. And now we try to formulate it as an MDP problem. So we define the states, the policy networks, action space, transition, and the rewards we should have. So first, for the states, what we have is a new concept we call slots. Slots is the placeholder of the potential item in the bundle. For example, we may have 3 slots for outfits, like a slot for hats, a slot for shirts, or a slot for pants. And then, for different conversation round, slot will change. Currently, we use a very simple heuristic rule to define the number of rows, number of slots per round. But now, we just want to mention that with different slots, we can collect different user feedback into the slots to different type of item. And then we can define the states based on the slots and the feedback we collected to the slots. Later, as we mentioned before, we have a policy network decide whether to ask questions or recommend something. We also have a policy network that can decide what is the text we should select during the conversation. We also have another network that can be responsible for what is the multiple items we should generate as a bundle to the user. So we have 3 types of policy networks and the related action space. We define the transitions and also the rewards to different policy networks. And welcome to check the details in our paper. So now we move to the next part. It's about our model. Our model is designed under the framework of our bundle MCR. And model design and training strategy are driven by 2 questions. The first question is how to encode the state and how to update it to the next state for the conversation. Our solution is to provide a BERT-like model we call BONT. BONT is a model that can treat the problem like predict the generated models or generated items or generated tags for the current conversation round as a task to fill the slots. Another question is about how to effectively train the multiple policy networks, because if we deploy this model to an online environment and train from scratch, it's really hard to get good results due to the sparse rewards. So our solution is we try to do some offline pre-training first, and then we fine-tune our model in an online environment. This is the architecture of BONT. So naturally, the BONT is BERT-like model. During conversation, per slot, we will collect different feedback. For example, for the first slot, maybe we know the item token is accepted, or we know some information about the category token or the attributes token. So we have some known token, but also we have some unknown token for example, for the second slot or the last slots. So based on the known token, we use the BERT-like model to predict what is the information for the unknown token. That's what we have for the BERT-like model we call BONT architecture. And what we want to do is to fill the slots, fill the mask token. And next, if we have the BONT architecture already, what we want to do first is to pre-train the model with the offline datasets. In the offline datasets, what we have is the historical interactions with the bundles in the offline datasets. For example, we have some datasets collected from Steam. There are some interactions for the user with the bundle of games. So if we want to pre-train it offline, the first thing is we sample one of the bundle, and then we randomly mask the information, like the information of some of the item or some of the tags of the item in this bundle. And then our model is required to predict the masked item or masked tags correctly. So that's for offline pre-training. It's like a mimicking of what we should do for the generation per conversation round. And later, if we have a pre-trained model, the model can gain the basic knowledge about how to make the recommendation for some reasonable items or tags. So now we deploy this model to an online environment, The first thing is we fix the parameters of our bound backbone. And then we try to follow the pipeline we described in the bundle MCR to recommend something or post questions and collect the rewards from a user. The user can be a real user or simulated user. And later, this model can be updated, or these agents, like for tags or for items, can be updated after collecting the trajectories from this online environment. Okay, so now let's see some results. First, we have some results about automatic evaluation. There, we have 4 data sets and 2 groups of baselines. The first group of baselines is the individual MCR. That's the existing MCR models, but they are not considering the bundle information. Another group of the baselines is bundle recommender. The bundle recommender can recommend a bundle in one shoot, or for a fair comparison, we can allow to generate bundles for multiple runs. And later, what we should have now is the user simulator. We simulate the user by training on an additional parts of the data sets so they can provide the reaction to the post questions or the generated items as a bundle. So the first finding is if we compare our model with the bundle generator without any conversation mechanism, the results shows the effectiveness of incorporating the conversation mechanism. And the second finding is if we compare our model with the model only use the individual MCR, it shows the effectiveness of considering the bound design and the special bundle-aware information in the MCR setting. And we also test our model bounds in a traditional bundle generation scenario. And interestingly, bound itself has a sort of performance compared with the traditional bundle generator. Also, we plot our cumulative accuracy curve. The x-axis is the conversation round, and the y-axis is the cumulative accuracy we could collect it from the conversations. So the finding is our model usually provide results they can outperform the baselines in the late conversation rounds. That makes sense because we need more time to ask some questions and collect more information from a user. But there also remains some challenges because in the real world applications, it's highly possible that the user may lose patience if we have a longer conversations. We also provide some human evaluation with a simple idea. The idea is we try to select the best conversation trajectories from the trajectories generated by our model or the baseline models. And the results from MTurk also show the benefits of our design. And now let's go to the conclusion. Our conclusion is our work is try to introduce the conversational mechanism to solve or to help the problem of the bundle recommendation because that's a very challenging problem itself. And we extend the MCR setting to the bundle-aware setting and formulate it as an MDP problem. Also, we provide the bound architecture and use a 2-stage training strategy to make it work and show the effectiveness with some evaluations. But also, we have some challenges still and some interesting directions in the future. The first is how to extend it to a free text conversation system instead of a tag-based system. The second is how to unify the conversational bundle recommendation with the existing individual item recommendation system because individual item can be treated as a special bundle. And the next is about we could have a more comprehensive human evaluation by designing an interactive interface and request some users to play with this system. And we are also open to other discussion. So thanks. And this is the link for our paper and the code. Thanks.
Thank you very much for that very nice talk. Due to the time limitation, I'm going to ask you, we have time for one question. Could you say something about how you generated the bundles for the evaluation from the offline datasets?
Okay, offline datasets, for the offline datasets, actually we collected we have 4 data sets, and 2 of the data sets, let me check, like the Steam and iFashion data sets themselves have the rating to the bundle. And for movie lens and clothing data sets from Amazon, they have no explicit bundles. Actually, we just group the items with a specific time interval, for example, within a day. We treat it as a bundle. So that 2 data sets are kind of simulated, and the Steam and iFashion, they are real bundles.
Clear. Thank you for the clarification. Thanks again.
Thanks.